Hello, and welcome to our session on open and integrated analytics on Google Cloud. In this session, we will share our vision for helping you integrate open source analytics into your data strategy, share more details about our exciting announcement around Spark on Google Cloud, and discuss how Snap is using Google's data analytics portfolio to build a data mesh architecture. By the way of introduction, my name is Irina Farooq, and I lead product management for our open data analytics portfolio. And joining me today is Saral Jain, Director of Big Data Infrastructure at Snap. Welcome, Saral, and thank you for taking the time to be here to tell us about your journey with Google Cloud. And of course, thank you so much for your partnership.
Thanks, Irina. It's great to be here. Thanks for having me over here. I'm Saral Jain. I am a director of engineering at Snap, and I run our infrastructure and data teams. And I appreciate our close partnership with Google, and I'm looking forward to the discussion.
As many of us are aware, and especially those of us that have been in the industry for a while, we're living in the golden age of open source software. With enterprises across sizes adopting open source software, and the growth of adoption is only accelerating. In fact, 99% of Fortune 500 companies use open source today, and over 80% are planning to increase their investment in the next 12 months. The same pattern and even accelerated pattern is seen in data analytics specifically as well. As companies double down on their open source investments, they're no longer looking at them as a separate corner of their data infrastructure. Instead, they're looking to integrate open source analytics and processing into the core of their data platform. At Google Cloud, we have been helping customers modernize their open source analytics with Cloud Dataproc, and then helping them integrate that into the rest of the Google Cloud platform. Companies like Metro, Broadcom, and Vodafone are using Dataproc to modernize their data analytics architecture, lower their support and infrastructure costs, and really increase the diversity of their data ecosystem. As we have been on this journey for the past 5, 6 years of helping customers modernize some of the largest Hadoop deployments in the world and bring those to Google Cloud, we have learned so much about what it takes to manage and run those deployments. And this is why we're super excited to double down on our commitment to open source in general and Apache Spark in particular and deliver the best experience for Apache Spark on GCP. This week at Next, we're announcing Spark on Google Cloud. Our commitment to making Spark a first-class citizen on GCP for all your workloads, ETL, data science, and exploration. There are three key pillars to our announcement. First and foremost, I'm excited to announce industry's first auto-scaling serverless Apache Spark offering for all your workloads. Now, what we're striving for is to bring you the same simplicity you're used to with some of our native services to Apache Spark, removing some of the manual toil and complexity typically associated with Spark deployments. The second key pillar of our announcement is pervasive Spark experience, integrating serverless Spark with some of our leading services like BigQuery, Vertex AI, Dataplex, and Composer. Now, your data scientists, engineers, developers can use Spark seamlessly in their tools of choice. And last, but definitely not least part of our announcement, is our commitment to giving you the flexibility in how you consume Spark. In addition to the serverless announcement this week and our existing Spark on Compute Engine offering, we're also excited to announce Spark on GKE, giving you the flexibility to standardize on Kubernetes if you choose to do so. Now, as you see, we have a full spectrum of offerings from Spark on Kubernetes to Compute Engine to a fully serverless offering, giving you the flexibility to pick and choose the right form factor for the right workloads while making Spark accessible to the end users in their tools of choice. Let's take a closer look at some of the core pillars of this announcement. Spark developers today spend only 40% of their time writing code. The remaining 60% is spent on planning, provisioning, and maintaining infrastructure. This is really stems from the fact that while being a super powerful distributed processing framework, Spark is also incredibly complex with lots of potential configurations and knobs to tune. At Google Cloud, we're on a mission to give developers their time back. So you don't have to worry about infrastructure at all. You write the code, submit the job, we take care of everything else. From configuring the intelligent defaults to auto scaling to infrastructure to optimizing infrastructure usage over time. On top of that, unlike the other competitive solution in the market where you have to pay for the infrastructure time, with our serverless Spark offering, you only pay for the job duration, period. Of course, all the intelligence of serverless Spark and everything I've described to date, while that's all good, we want to make sure that you can integrate that seamlessly into all the different workloads within your environment. In addition to providing a very robust set of APIs, we also have taken great care to integrate serverless Spark with some of the leading services in our portfolio. Let's take a closer look at some of those integrations. The first major integration is Spark on BigQuery, giving BigQuery users the ability to run Apache Spark straight from the BigQuery console. What we've done is we've integrated a PySpark editor into your BigQuery console, powered by the serverless Spark backend. Now your data scientists and analysts can get the same seamless serverless auto-scaling experience for Apache Spark as they're used to with SQL, straight from their BigQuery console and all of the data in BigQuery. For those of you looking to leverage Spark for data science and machine learning workloads, we have integrated Spark with Vertex AI, our unified AI platform. Now, data scientists can leverage Spark with just a single click straight from the Vertex AI workbench. In addition to Spark, they can also combine that with other machine learning frameworks like TensorFlow, PyTorch, Scikit-learn, and of course, BigQuery ML. All of Google Cloud's security, compliance, and IAM are applied seamlessly across Vertex AI and Spark. And as you're ready to take your models from the lab and into production, you can seamlessly deploy them as jobs within Dataproc, as well as schedule them with AI pipelines. And for those of you looking to build a unified platform across distributed data, Dataplex, our distributed data fabric, provides centralized security and governance, intelligent data management, and integrated analytics experience across your distributed data in GCS and BigQuery. And this is why we're so excited to integrate Serverless Spark and Dataplex out of the gate, as both of these products are being announced in GA at Next this week. Now your data scientists and analysts get a seamless serverless collaborative experience across SQL and notebooks powered by Apache Spark across all of their distributed data with unified security and governance. As I've shared a lot of details about the latest announcements, At this point, I'd love to welcome Saral back to talk about Snap and their data architecture. Welcome, Saral.
Thanks, Irina. First of all, those are some really cool new feature launches. So, congratulations to your team, and I'm looking forward to the discussion.
Thank you so much. Um, could you maybe, by the way of introduction, could you tell us a little bit more about yourself as well as Snap more broadly for those who may not be as familiar?
Yeah, absolutely. So, I'm Saral Jain. I'm a director of engineering at Snap. Snap builds an app called Snapchat, which hundreds of millions of people around the world use to express themselves and have fun with their close friends and family. We built features like AR lenses, maps, Bitmoji, and Spotlight to allow people to use the Snap camera, which is our home screen, to express themselves through the power of visual communication. My role as the leader of infrastructure and data at Snap is to ensure that Snapchat scales to our entire global community and provides a reliable and fast experience to all of our Snapchatters. As part of this, I also lead teams that build a centralized infrastructure for data that powers basically all of the features on the app.
Wow, that's really impressive. And, thank you. I think this session alone has made me cooler with my kids that I can say, I just play a small role in helping, Snapchat evolve. So thank you for that. Could you share a little bit more detail on how does Snap use data today?
Yeah, absolutely. So at Snap, we really believe in data-driven decision making. That basically means data powers all of our feature development, research, analytics, experimentation, machine learning, advertising, as well as business reporting. So those are our primary data use cases. To make this possible, we collect over 900 billion events every single day from our Android and iOS clients, wearables like spectacles, and the thousands of microservices that are running on Google Cloud. To put that in perspective, that is almost 2 petabytes of information every single day we ingest into BigQuery, which is our central data warehouse that powers all of our analytics.
Wow, that is really impressive scale. But dealing with data at such a massive scale, what have been some of the biggest challenges facing Snap in terms of data usage?
Yeah, I think first, as I mentioned, just the sheer scale and volume of data presents unique technology challenges. It's certainly not trivial to build systems that can handle this scale of data. Second, and maybe more interestingly, while doing this, we need to put our users' data security and privacy first. This brings in unique challenges around data compliance, governance, and privacy that actually inform all of our feature development. In fact, I think one of the biggest challenges in the industry right now is around ensuring that we are being responsible with how we collect user data, store user data, and delete user data. And while this is a big challenge, right from the early days, Snapchat has been a pioneer in the industry in terms of building privacy first features like ephemeral messaging that are designed from scratch to keep our user data private.
That is very helpful context to help understand the scale and the scale of the challenge that really your team is facing to keep the trust and the privacy of the users. I know Snap and Google Cloud have enjoyed a successful partnership to date. What does this partnership mean to you, and how has Google supported Snap through this journey?
I mean, honestly, Snap and Google Cloud have basically grown together, and we have really enjoyed the partnership. From my perspective, Google Cloud has taken on all of the undifferentiated work of providing a secure, reliable, performant, and cost effective platform so that we can focus on what we do best, which is building delightful features for our Snapchatters. As a result, at this point, we almost use every single data and analytics services that is offered by the Google Cloud. Google Cloud has helped us scale in at least three different dimensions. One, as I mentioned, is the volume of data as we have grown to petabytes of data. Second is the complexity of our use cases. So we have gone from batch offline analytics to a more real-time streaming platforms that can build features like Spotlight and Maps. And then finally, and I think most importantly, it has helped us democratize data within Snapchat as we have hired hundreds of engineers and data scientists. Having access in a secure way to all of this data has enabled us to accelerate our feature development and again build these innovative features. And I really appreciate the close collaboration with the Google team to make all of this possible. I know there have been cases where our teams have actually worked together, literally worked on calls to brainstorm solutions to our problems, which I really appreciate. And you guys have been great partners to do that. Also love how easy it was to integrate Google data services with our own custom and open source solutions. This flexibility with open source solutions like Spark and Airflow was key for us to feel comfortable with our technology choices. Especially with today's launches on investments in serverless Spark, it continues to give us the confidence that Google Cloud is invested in meaningful integrations with these open source solutions, and it's always great to see.
No, that's very helpful. Thank you, Saral, for that. I know that, you, especially in your team, are driving this compelling vision for data mesh and, how you see your data architecture evolving over time. Would you mind sharing some of the details about that and how you envision that playing out, for Snap?
Yes, absolutely. So essentially, we have hundreds of petabytes of data stored across tens of thousands of GCS buckets used by hundreds of internal teams. Each of these internal teams have built their own custom data pipelines and infrastructure to process all of this data. And this duplication is not just inefficient in terms of cost and engineering effort, but also a big concern for us in terms of data compliance and privacy. So it was basically where we called it a data mess. And to solve this problem, we have proposed building a completely new solution that is essentially a centrally managed, singly cataloged, multi-tenant platform that enables all of the teams at Snapchat to run their data pipelines. And this platform is what we call the data mesh platform. There are essentially three primary problems that data mesh solves for us. One is the data mesh catalog that creates an authoritative and central place where all of the metadata across the company is cataloged. This central place can help us give a central choke point for enforcing things like data compliance as well as driving out inefficiencies. The second major pillar is data mesh runtime, which helps in onboarding all of these duplicate pipelines I talked about into a centrally managed Spark-based runtime that reduces all of the undifferentiated overhead from all of our feature teams. And then finally, we have the data mesh lake, which is a logical layer of data organization across all of the data we have in GCS that improves data discoverability. So across the catalog, runtime, and lake, we have built this data mesh, which is a standardized data infrastructure at Snap that can help us continue to innovate while keeping our user data safe.
No, that is very helpful to understand. Your team has been working so closely with us in helping provide guidance on serverless Spark and Dataplex. I'd love to hear your thoughts on how do you see serverless Spark and Dataplex fit into your data mesh strategy and help solve some of the challenges that you described.
I'm actually really excited about serverless Spark and Dataplex, and they fit seamlessly into our data mesh strategy. Let's talk about serverless Spark first. So serverless Spark is going to be a critical component of our data mesh runtime. Uh, Essentially, when I think about our data usage, there are two kinds of users at Snap. One are the big teams who are well invested in their data infrastructure, run really large jobs, and they are intentionally thinking about optimizing scale and complexity of these jobs. And then there is the second category, which is basically the rest of our company who are not typically staffed to build, own, and operate big data jobs at our scale. These are typically our feature engineering teams. They just want something that works, and their priorities on shipping features, not dealing with the idiosyncrasies of Spark. And I think the second category is like 80% of our use cases. And I think this is where serverless Spark can play a big role, where it can solve all of these problems for the feature engineering teams and let them allow them to build unique features. In terms of Dataplex, we think it will significantly accelerate our data mesh catalog and lake solutions. As I mentioned, we have hundreds of petabytes of data stored across GCS. And Dataplex will help us make this GCS data discoverable and compliant. It will also encourage data reuse across teams, which will help us build more integrated features across Snapchat. And especially features like data auto discovery, BigQuery integration, data quality monitoring, as well as PII detection, all fit in very nicely with our vision of data mesh. And I'm really excited to kind of onboard this to our data mesh.
No, thank you. This is so, so helpful. And really, you have challenged us and provided guidance to us on how do we think of all of this, the different data stores and the different engines within GCP as part of that integrated platform where we help give you that flexibility to use BigQuery, Spark, Dataflow, all the different, both native as well as open source services, but giving you the central governance and flexibility. So, Saral, I cannot thank you enough for your partnership and for your guidance on this journey with us. For everyone else in the audience, if you want to learn more about some of the announcements we announced today, please go to our website as well as the blog and express interest to try out some of those capabilities. Thank you very much, and thank you, Saral, again for joining us and sharing the story of Snap.
Of course, I'm really excited about Google continuing to innovate in this area for us, and I look forward to continuing our strong partnership.
Thank you.